One of the most important aspects of 3D modeling is the creation and maintenance of sketches. Sketch constraints, in addition to dimensional constraints, can be considered the logic that tells all of the geometry that makes up a particular sketch how to relate. Using the proper sketch constraints for a particular set of geometry is very important because if the sketch is not constrained correctly, especially if the geometry is driven by parameters or iLogic, things can go very wrong. In this lesson, you will drive a model to the point of sketch failure and then use the Show Constraints for Selected feature to find and fix the problem. On the ribbon, Manage tab, iLogic panel, select iLogic Browser to display the iLogic browser. If the browser isn't docked, drag it over and drop it below the browser bar. Switch to the Forms tab if it isn't selected already. Select the Drive Model Form button and the Drive Model Form opens. There is only one control on the form that allows the model to be driven via the underlying sketch. The desired outcome is to change wall A from 48 inches to 51 inches. Expand the drop-down on the form and choose 51 inches. The wall A section of the model deforms, and the Decal A feature fails as denoted by the error icon seen in the browser. In other words, the model has failed. Before continuing, reset the wall A length to 48 inches. Double-click the wall layout sketch in the browser to activate it. You can see by the notification area in the lower right corner that the sketch is fully constrained, so that is not the problem. Now look at the dimensional constraints. You can see from the dimensional constraints that wall A and wall B are the same size, 48 inches. Because nothing happened to wall B when the model was driven, these constraints must have different parameters. To see what they are, right-click any dimension and choose Dimension Properties from the context menu. The Dimension Properties dialog box opens. Select the Document Settings tab, and on the Modeling Dimension Display drop-down, choose Show Expression. Click OK. The dimensions now show the names of any associated parameters. Notice that the two walls are being driven by different parameters. That explains why wall B did not change size when the model was driven, but it doesn't explain the failure, at least not fully. To see what is going on, you'll need to take a look at the geometric constraints. The top line of wall A is where the failure happened, so check its geometric constraints first. Select the top line, and notice that besides the coincident constraints, which are represented by the yellow squares, there is a parallel constraint. Hovering the cursor over the constraint shows that the top line is parallel to the line just below it. No problem so far, so check the lower line. Here, you see the other half of the parallel constraint you just saw, along with a vertical constraint, which is fine, but the last constraint is problematic. It is an equal constraint, and having already looked at the upper line of this wall, you know that this line is not equal to the upper line. Hover your cursor over the equal constraint, and you can see that the line is equal to one of the lines from the other wall, which is causing the line to remain at 48 inches, while the top line increases to 51 when driven. This is the problem. To fix it, select the equal constraint, then press the Delete key on your keyboard. Notice that several of the lines change color to show that they are not fully constrained, and that the notification area shows that one dimension is needed. The problem in this case is that someone changed the constraints without knowing the full design intent. A perpendicular constraint on the end of wall A was removed in favor of an equal constraint. You have already removed the equal constraint, so you just need to replace the perpendicular one. Select the perpendicular constraint command from the constraint panel, and then select the top line of wall A. Now, hover over the end line of the wall until the non-construction line highlights, and then click. Right-click and select OK. The line colors are now all the same, and the sketch is fully constrained, but there is one last thing that needs to be fixed. The construction line is supposed to show the outer border of the room, but it is connected to the end of the wrong stud. To fix this, click the longer line to show the coincident constraints. Right-click the offending constraint and select Delete Coincident Constraint from the context menu. Drag the line down and away, then use the coincident constraint from the constraint panel to reattach its endpoint to the end of the wall. Right-click and select Finish 2D Sketch from the marking menu. Drive the model again, and all is well. The ability to diagnose and repair sketches is an incredibly important aspect of 3D modeling, especially when the model will be driven by its parameters. Proper use of constraint discovery and modification commands will help you keep your models running smoothly.